Now for some lines. Specifically, we'll do secant lines, but I'll start with a quick review of the basics of graphing lines. So this will probably be familiar, but it's good chance to review. So we're graphing a function, all the x values versus y values as dots. And this time our function is going to have the format of just any number times x plus any number. Those could be fractions, whole numbers, decimals, but nothing can happen to x except just multiplying by a constant and or adding or subtracting a constant. So when that's the case, you know the graph is going to be a straight line. And you can plot some points. Like in this one I have constants 3 and 2, 3x plus 2. If you put in 0 for x, you get out for y 2. And so I put a dot there on 0, comma 2. And if you put in 1 for x, you get out 3 plus 2 equals 5. So there's a dot there. And then if you draw the line through those two dots, you now have all the other dots possible. Every other point of that function, x comma y, will be on the line. The format in letters is y equals mx plus b. And here m is the slope. That tells you how steep it is. If it's a positive number, that means it's going up from left to right. Negative numbers will go down from left to right, and bigger is steeper. And that's because you always put the change in the vertical, which we call the rise, or just change in y, over the change in horizontal, which we call the run, or change in x, for the same amount, the same period of the same 2 points. So rise over run is the slope. And b there is the y-intercept. That's where it crosses the y-axis. So for this example, the 2 points you could look at, I drew some little dotted lines. You can tell that as it goes from 0 to 1, so with just a horizontal distance of 1, it goes up by 3 from 2 to 5. So the slope is 3, where the y-intercept is 2. Now, another very useful format is the point slope format. It comes up a lot when there's 2 points on a line and you have to calculate the slope, or it comes up in calculus when you know the slope from taking a derivative and you have a point on the line. So, but for now, I'll remind you how to find the slope for 2 points. So here's 2 points on just an arbitrary line. I called the points P and Q, but their real name would be x1, y1, for just an x value and a y value that go together, and x2, y2. Then the slope is the change in the y values, so y2 minus y1, and divide by this change in the corresponding x values, x2 minus x1. Got to keep the 2's over 2's and 1's over 1's there. So once you find the slope, then you can pick either one of those points. I picked x1, y1, and write down the formula for the line, which would be y minus y1 equals m times x minus x1. Doesn't matter which point you pick. You could also pick the other point or some other point on the line, x2, y2, or anything else. If you do write it down like that, you also have the option then of simplifying it by multiplying through the parentheses and adding up the constants to get back to the slope-intercept form, which will give you the same answer no matter which point you use to begin with. Now for secant lines. So, secant lines are defined using some other function besides a line, usually. Something like a curve, like here I decided to use 3x squared minus 1, and here's a picture of it. It's the curved parabola down at the bottom there. It will be a secant line, will be through 2 points on the curve, and you'll have to at least know the 2 x values. You can also find the 2x, or they'll have to at least tell you the 2 x values. They might tell you the whole point. And then, but in this case, I do an example here. I said let x1 equal 1 and x2 equals 3, and you're going to have to find the 2 y values. So to find the y value for a point P, which I drew down here, first I plugged in x equal to 1, and then that says to square it, order of operations, then multiply by 3, then subtract 1. So I get just 3 minus 1 equals 2. When I plug in 3, I square it. I then multiply the answer by 3 and subtract 1, so I get 9 times 3 is 27, minus 1 is 26. So those are the two y values. And then the secant line is just the line through those 2 points. So you do need to find the slope of it. That means the difference in the two y values, which I just found, 26 minus 2. Divide by the distance in the 2x, the difference between the two x values, the distance between them. And those were given, so I do 3 minus 1 and get 2. And that means that this line is pretty steep. It has a slope of 12. 24 over for every, or 24 up for every 2 over, so 12. Then you write down the equation of the actual line. So I use my point slope form for that. I picked y minus 2, so that's using the point P equals 12 times x minus 1, the x value of that point. And this point, you'll have to look at the question and see if it says to leave it in point slope form, I'd be finished. Or if it says simplify to slope intercept form, then you have to multiply the 12 through the parentheses and add the 2 to both sides of the equation and get that slope intercept form, y equals 12x minus 10.